Alright, once again, time for another test for convergence. This one is called the root test. So at the end of this lesson, you'll be able to determine whether an infinite series converges or diverges using the root test. Alright, first of all, when would you use the root test? Whenever you have powers in your problem, lots of powers, that would be a perfect time to use the root test. One thing that's really nice about the root test, first of all, let's just look at this. Suppose that the limit as n approaches infinity is equal to the nth root of your sequence. We will get an answer, and then the rules are the same as the ratio test. So if p is less than 1, your series will converge. If p is greater than 1 or infinite, the series will diverge, and if p equals 1, we are inconclusive and we'll have to try a new test. So that's pretty much it. What we'll basically be doing, if we have powers, we will take the nth root of the sequence and let n approach infinity and see what happens. So let's go ahead and try an example. Does the series n equal 1 to infinity of n squared over 2 to the n converge or diverge? You might be looking at this and thinking, oh, I think I'd like to use the geometric series on it because you see to an n power, but we've got that n squared hanging in there, so we are going to try something different. So we are going to, since there are powers, there's actually a 2 and an n for powers, we are going to use the root test. Alright, so the root test again says we're going to find the limit as n approaches infinity. We're going to take our a sub n and we're going to take the nth root of it, and we're going to see what happens when we do that. Well, when we take the nth root of that, since I have it under one big fraction, I'm actually going to split it into two fractions. Okay, and then this first, the top one, I'm going to rewrite as n squared. I'm not going to write it that. I'm going to write it as the nth root of n, and then I'm going to square that result. And then down on the bottom, the nth power to the nth root, they will cancel each other out, so I'm just going to be left with 2. Now, if you remember our limits that arise frequently, we found out that the limit as n approaches infinity of the nth root of n is going to equal 1. So we'll get 1 squared, which is 1, over 2. So we just found out that our limit was equal to 1/2. So we can now say, since p is equal to 1/2, which is less than 1, the series n equals 1 to infinity of n squared over 2 to the n, we have just found out that it converges. So that's all you need to do on that problem, and hopefully you are now familiar with using the root test to test for convergence.